Hey everyone, in today's video, we've got a mighty Marantz 240. This Marantz 240 came from the estate of my neighbor's late father. I have not turned this on. I do not know if it's broken or not. He doesn't know either. So we're going to go through this together. We'll get it on the dim bulb, see what's going on, and if it needs repairs, which I think it's going to, we will take care of those in this video. The only thing I've done with this so far is I've taken the top cover off and I've looked inside and, well, it's actually pretty clean. So we'll see if that adds up to an actual functioning power amplifier. Let's take a closer look. So I've seen the Marantz 240 before, just looking around on the internet, learning about Marantz models, etc. But this one has like a black anodized aluminum face with white lettering on it. I've never really seen that before. I thought that was pretty interesting. So maybe this is a super rare model. Who knows? Beyond this little cage here, there's going to be 4 output transistors. Can't see them too well, but they're there. And then on the other side, same deal. Another 4 output transistors for the other channel. This thing is rated at 120 watts per channel, which is quite significant for the time. This is one of the last Marantz components to be made in the USA. And you can see right there, precision crafted in the USA. So that is pretty cool to see an actual American-made Marantz, one of the last ones. And that's evident once you look inside. All the stuff inside of here is very different compared to like a 22 series stereo receiver, like a 2270, which was sold in a similar time frame. This is early 70s. Going back over here, this is a very, very simple piece of equipment. You've got inputs and you've got outputs. You're supposed to use this with a dedicated Marantz preamplifier, like a Model 7, but I think they sold more of these individual amplifiers than they did preamplifiers. So what a lot of people may do is they'll take this and they'll hook it up to their stereo receiver, like that 2226 we just had on the channel. We can run the preamplifier out and go right in here with our right and left channels, and we'll get a 120 watt per channel power amplifier instead of a 26 watt per channel. Right, Hodor? So I've looked in here, but let's get this cover off. And once we're in here, we see very simple. Now, a lot of people are familiar with the Marantz 250, which has meters in the front here. And that makes it a lot cooler, yes, but if you didn't want to spend the extra money to get the cool meters, you got this instead. It's just a box with a power light on it. You can see there's your lamp right there. That's going to light up on the outside and you'll be able to see if it's turned on or not. So it's quite simple. You've got big old transformer that has been tested. You've got big, massive filter capacitors that probably need to be replaced. You've got regulated power supply board, and you've got power amplifier board for each channel, right and left. X-Ray Tony B just did an excellent series on a Marantz 250, and a lot of that same stuff applies to this. Like, for example, we know this is an early model because we don't have any bridge rectifiers up here, or diodes. We see that they are buried down in there on the power supply board. So we're going to have to take a look at those. We'll look at the solder joints, make sure they're okay, do anything necessary to make it better, and maybe we'll replace these filter capacitors. Maybe we will recap these boards. You know, this is honestly a pretty good candidate for a full restoration, so we'll see what kind of condition we're in when we power this thing on and go from there. Okay, so I turned off the overhead light so we can more clearly see this bulb. This is a 100 watt bulb, and I would expect that we would see it light up pretty bright when we turn this on. Man, I just realized I don't even see a power switch on this thing. That's how simple this power amplifier is. So we're going to have to assume that it's turned on and flip the switch. Alright, let's do it. See what happens. Just as I expected, bright bulb goes to nothing. Is there a click? Oh, okay, that startled me, but that is not the first time I've heard something like that happen. Actually, the very first Marantz I ever had, the relay would buzz before it would click in. Since we have a relay click, that means that there's not terribly bad DC at the speaker terminals, in theory. So let's take a look with our multimeter and see what we've got back there. So let's take this cap off. So on the right channel, what we have here is 38 millivolts DC. That's pretty dang healthy. And on the left channel, we have 47. Also, honestly, fairly healthy, especially for how old this thing is and how we know that they can actually be kind of unstable in ways. So that's great news so far. Now we need to get a service manual and figure out how you check the amplifier's bias. Okay, change of plans. This thing's been sitting turned on for like 15 minutes now, and there is no heat to be felt on either one of these heat sinks. So the bias is probably fine. The fact that we have acceptable DC offset makes me curious to hook up some speakers to this thing. Let's get a source plugged in here, and we need to remember that since this is a power amp and we're not hooking up a preamp, we're going to need to make sure that our source, this old phone here, is turned down very low in the volume. So our right channel is dropping in and out for some reason, and I don't know why. I can hear it trying. So there, it's dropping in and out for some reason. But left channel sounds stronger. It also sounds quite good, honestly. Okay, so I think we know what we're in for here. We've got one channel that works, one channel that drops in and out. We've got a dirty freaking relay, power supply that's probably in need of quite a bit of help. So, you know, since this is a Marantz 240 and they're kind of sought after right now, I think that what this is going to turn into is a restoration video. And that means this is not going to be the only day I record on this. So I gotta take this thing apart. I've got to figure out what's inside, order the parts. There's lots of capacitors on this thing that should definitely be replaced, so I guess I'm going to go shopping on Mauser, but we can work on taking this thing apart a little bit before we do that. Right, Sadie? Do you want to help take it apart? Are you good with the screwdriver? What do you think? What do you think? What do you think about the Marantz 240? No, 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 no. Cat. Yeah, real quick before I tear it apart, all I did was literally just tap that relay in there, and the right channel has not quit since, and got both speakers hooked up. Sounds okay. Oh, there we go. So the right channel just quit, and I'll bet you if I just tap it again, yeah, just giving it a little tap. Let's tear this thing apart. Let's get a closer look at it. We're going to be able to tell much more things once we get it apart, and it's not going to be too hard to get it apart. Okay, so right in here is where we're looking. We're looking at the power supply board. And this is what we're concerned about, these diodes right here, because these are big, high current diodes that get pretty dang hot down here. So hot to the point that when they redesigned this amplifier, they actually relocated them so that they were sitting kind of up here. So the bridge rectifier was, you know, right by the capacitors where it needed to be. So what happens is these get kind of hot, and the first place I'm checking is these solder joints back here, and I'm pretty happy to report that I really don't see any bad joints back here. I mean, they don't even look like they've been heat stressed or anything. Like maybe that one a little bit at the lead, but nothing here that's kind of screaming to me, you know, like this has been abused, this is in bad shape. Everything in this looks pretty good. So on this board there are 1, 2, 3 axial electrolytic capacitors that are probably in bad shape. And you know, this relay, obviously a point of contention here. So those four things should definitely be replaced on the power supply board. And what I'll do anyways is I will reflow the joints on the bridge rectifier diodes. Now, as I move over to the left side power amplifier board, toward the bottom in here, I see evidence of you know, things going wrong. There's some discoloration in the PCB, and I'm not quite sure what that is all about. If I look up on the other side, or the other channel, there is not discoloration over there, and the components all look to be the same, except for maybe this resistor right here. So I'll definitely be checking this resistor right in there, the one that kind of goes away when my finger goes in there. Otherwise, looking at the rest of this board, there's a few electrolytic capacitors, one there, there, and there. I also just noticed, looking insanely closely in this area, it looks like this resistor that has all this stuff going across it in parallel, the case of it might be cracked, so I'm going to look at that and make sure that's okay. Let's go over to the right channel amplifier board. That's right over here. Zoom out a little bit. This one looks better than the other one. It's got all the same stuff, you know, there's your diff pair right there. This is the resistor on the other board that was all discolored and, you know, is still discolored. And I don't know why, so I want to figure out why that is. But yeah, this whole board looks fantastic. There's nothing visually wrong with any of this stuff. Kind of a beautiful thing here. There's not much to it. It's a very simple machine. Okay, someone's been here. We've got 4 NTE power transistors in here. NTE 284 and 285. So we do not have original power transistors, unfortunately, on this channel, and that might explain why we saw what we saw with the stuff over there. Let's check the other channel. See if we've got originals over here, since this board's actually in good condition. This one we do. We've got nice Motorola transistors in there. That is indicative of original transistors. So, good stuff here. Too bad about the other side. We'll make sure those transistors are up to the task. So, yeah, that all got recorded in December. And now we're here in August. And now we're gonna fix this. So yeah, this all looks quite familiar, gotta say. Let's start going through our goodie bag, because I did buy a lot of stuff. We've got multiple values of Nichicon PW capacitors. We've got a new relay. There she is right there. Nice big beefy contacts right there, so that should be pretty okay. We've got the new filter, guys. I'll put the part number in the video if I remember. This is what I was able to get at the time. They're 80 volt 22,000 microfarad capacitors. That's about on par with what we had before. X-Ray Tony B, I'm going to be talking about him a lot in this video, because we're going to be doing some of his tips and tricks on this amp. He was able to get, I think, 33,000 microfarad capacitors at the time he did it, but I was not, because, yeah, that's just kind of how it is with the filter capacitor game. They either have it or they don't. Before we add these filter capacitors, we're going to want to look at restoring this power supply board. I think the first thing to do here is remove this relay, because that relay sucks. We are not going to use it again. So, yeah, while this filter capacitor is out, look how much easier it is to bend this down and get to these solder joints. So that's really nice. Let's heat up the Heiko FR300 and go to town. What? What is it? You want to say hi to the viewers at home? Where are you? There you are. There she is in the screen. She says hello. Hello, everybody. I'm the cutest, littlest kitty, and I say hello. able to just yank it now. Yep, there she blows. On this old relay here, this one's actually in better shape than most at this point in time. But you can see the contacts are, it's a little bit oxidized around there. Not exactly the best looking, but, last one of these I saw, I think one of the contacts was just straight welded to the other. Yeah, and, with this open, exposed style without the plastic cover on it, we could just clean it, but relays are mechanical components, like, no, just no. So now we run into the very unique issue with this stereo. We have a new relay here, but the pinout is actually different than this one, and the pins are also, a totally different style. So what do you do here? How do you make this relay go in here? Well, you can get real dirty with it, or X-Ray Tony B made some circuit boards. And yeah, I bought these in 2022. I had them delivered right before Christmas, it looks like. And this is an adapter PCB. He designed this, he put the Gerber file on his Patreon page. And what you do is you just take the relay and you stick it in right here. And then what we're going to do is we're going to solder some little posts into these tiny ones. And this is the pattern required to go into this circuit board. So it's a little adapter PCB. Very clever, very nifty. So if you want this, go on X-Ray Tony B's YouTube channel, find a link to his Patreon, and buy yourself a month membership, and you'll get access to this. It's not very expensive, it's definitely worth the money, and you get to support the guy. Okay, once you got it in here, then you buy some of these guys. These are just like little Samtech PCB post thingies, and you just break them off one by one with your pliers here. And you need 8 of them. Then you solder that whole thing together. Okay, so I soldered on the little pins first, then I set the relay in, and now I'm going to flip it upside down and solder the relay. So now we're able to stick this in, but the issue we run into is it's pretty loose in here. So what you want to do is you want to find a way to get it so you can get a little more wire jammed in there to get a better mechanical connection on your solder joint. X-Ray Tony B used like a thin foil stuff that you can buy at a craft store. I don't have that, so I was just gonna, figure something out on the fly. What I've done temporarily is I've just taken some Scotch tape to hold the relay in place so it doesn't fall out. Alright, so here's what I'm going to do. I just have some scrap wire laying around. It's just 14 gauge wire, and all I'm going to do is I'm going to just kind of set that in there. It's going to bottom out, and I'm just going to start soldering. And then I'll just take my cutters and cut it nice and short at the end, so the next time someone has to do this, they're gonna have a terrible time, because that's what I like to do when I work on stuff, is make it so the next person has a terrible time when they have to undo my crappy work. It's not exactly the prettiest thing I've ever done, but you can see him in there. That'll be just fine. So now we hope that let's get rid of this tape here and give it the wiggle test. That's solid. That ain't going nowhere. While we're in here soldering, I'm going to go ahead and reflow the bridge rectifier diode joints. All we're doing is we're just heating them up and adding a little more solder. That's all we're doing. Okay, that'll help those. Next, I'm going to remove these 3 capacitors because I know they're bad and it is not worth using them at all. So we're just going to get them out. We'll throw them on the tester just for fun, because I know some people are curious to see, just how bad is it. I've already got new PW capacitors in here. There's only 3 on this board. These 2 right here tested just fine, but this one here, you can see we've got some visual indication of stuff leaking out of there. And let's throw it on our capacitor tester right here. I'll show you what it does. So let's go. Open circuit, low capacitance. So yeah, not staying. But the other 2 tested fine, so that's interesting. Okay, so I've finished the power supply board. I've got the 3 new capacitors here. All the resistors tested fine. These are all probably fine. The relay is in. I'm not going to replace these 3. I don't know that I have a suitable replacement. X-Ray 20B said a 2N2222 works well for him on his curve tracer. I don't have one of those. I don't have a curve tracer. I don't have the proper gear to really go deep and find a proper replacement, and it's working as far as I know. So that's going to stay. So now that this is all finished up, I can bolt it back into place, and then we can start replacing these filter capacitors, since we're going to have no more need to do this. Once I do that, I'm going to put this thing back together loosely and turn it on to see if everything is okay. Alright, I've got this all reassembled. I just want to point out that these mounting brackets, these new capacitors came with new mounting brackets, and in order to install these, there's actually 2 washers and a nut, and you got to feed the screw from underneath and then drop 2 washers and then a 1/4 inch nut on top. And it is a enormous pain in the butt, but now I don't have a flathead inside, so that makes me happy. I don't like flatheads. So now it's time to get this on the dim bulb. So here's what we're gonna do. We're gonna plug our amp into the dim bulb, and this is technically a 3-way lamp, but I think it's 100 watt normal, because it says 50, 100, 150. Somebody can talk about that in the comments. We've got the bench turned off so we can see the light up. So I'm going to flip this switch. Let's see if we get a relay click, sparks, smoke, something. Let's find out. Are you ready? Let's go. That's exactly what you want to see. And perfect. Nailed it. So the relay clicks in, the capacitor's charged, that was the bright light, and then the light is now off, which means the amp is idling at some tiny current. This is exactly where we were before, which is exactly what you want to see. So now that our power supply is brand new, our protection circuit is run by a brand new relay, we can move on to these amplifier boards and start working on those and restore them, because they have capacitors and transistors that should probably be replaced. So let's get to that. Okay, so we're making our way into the first amp board here. My plan of attack for this is 1, replace the capacitors, which I've already done. There's 4 electrolytics. They all tested meh on the tester. This one was the worst, but you should just replace them at this point. They're really old. And just a quick little PSA to everybody. I was pulling the output transistors, and like I had mentioned earlier, these have the NTE output transistors. So somebody's been here before. Something happened on this side. But look at these pins here. See all that white stuff on there? That is thermal compound. Somebody was a little sloppy putting this together and got thermal compound on the pins. You can also see it in here on that right there. You see this a little bit of white on there. So now I gotta clean that and make sure these pins are, clean going into the sockets here, because thermal compound, I don't think that's electrically conductive. Correct me if I'm wrong, but I definitely do not want that on my contacts here, because this is where the music goes. Alright, a lot has happened since that last video I took. So this amplifier is tricky in that, like, there's a lot of things to know to get it right, and I'm trying to take it, very seriously and get this, as dialed in as I can and as reliable and safe as I can. This one is the old design from what I can tell. I think the 250 might have had a few other revisions, but as far as the 240 is concerned, this is the original, and then this is the revised, and we're working right here. The changes here, they're a little bit more complex than I wish to, mess with, so I just want to stick around up here. And there's a few things that I want to address, and I just ordered some parts from Mouser. Bunch of resistors. Why did I do that? Well, this amplifier has carbon comp resistors in a few places. They used them for the high power parts of it. So if I zoom in right here, these guys right here, these are carbon comp resistors. Maybe it's easier to see with the bench light off. If they're brown like that, it's carbon comp. And then this one right here, also a carbon comp resistor. So when I was testing this, I did figure out how to check the bias, and we'll do that later. It is performing. It is doing the 120 watts per channel on both channels, and that is awesome. But when this thing was just idling, like just doing nothing, these resistors right here, they're just bleeder resistors for these capacitors, so the extra charge has somewhere to go. Like if they didn't have this, these would just sit here fully charged and it wouldn't be all that good. So what I did is I touched these, and they were like extremely hot to the touch, and that's not really something you want to feel. Like these diodes weren't even that hot, they really weren't, but these resistors were extremely hot. So what I did is I ordered replacements. So I think these are actually 2 watt rated in the service manual. I got some 5 watt rated ones at a little bit higher of a value. So these are 3.3K, these are 2.2K. These are going to be just fine. They're going to do a much better job of dissipating the heat and taking the heat, frankly. And you've got a similar situation on the power amp boards. Like this one right here, this is literally just a dropping resistor. Like all it takes is rail voltage and it just drops it down to another voltage and it gets quite hot. You can see there's some other carbon comps in here, like you've got this one right here. And then underneath this mess is another carbon comp. It's a 39 ohm, I believe. And I'm looking at it closely and the case is actually cracked, so that's kind of interesting. And then down here there's another 39 ohm resistor. When I fixed that 1200B back in the day, which uses this, similar or same amp design, I found one of those 39 ohm resistors to be completely open. It had failed. We're going to up the power rating of all these carbon comp resistors in here, and I think that's going to add a lot of reliability to this amplifier. I think a lot of what happens is these resistors just get too hot and they'll fail, and then components going out of spec not being matched quite properly. We'll see how this all looks when we replace the resistors and how well we can get the bias to set and the DC offset to set. But for now, this is the approach I'm taking. I'm going to replace all of the carbon comp resistors on this board and this power supply board and the right channel that you can't see. There it is. We'll replace all the carbon comps on that too, and I still haven't done the capacitors on this right channel either. It hasn't been taken apart. I guess I'll try to walk you through all of that, but really it's not that hard. It's just buying metal oxide resistors on Mouser. You can just look for a T connectivity metal oxide resistor, and that's going to be what you want to put in place of these carbon comps. See, I had a suspicion something interesting was going on. You can see I've already got these replaced. Should I get them nice and straight with one another? Then I've got this one replaced and the one below it, and then I just started going right here, this funky little contraption that's got all the stuff in parallel with it. And I got it out, and then I looked, and this thing is completely toast. It's the case is cracked. There's black stuff right there. Look at that. And that there, folks, is a carbon comp resistor for you. So, yeah, this is the one I thought the case was cracked on, and it turns out, yeah, it's definitely cracked. And the one next to it, down here, well, it's all covered in remnants. I'm going to have to test each one of these components on this little thing here. And the craziest part of all of this is I ran this thing full bore, all the way up to 120 watts per channel. The bias set, the DC offset set, and it was running with this, so very interesting. I wonder if this happened when the other one failed, and this just wasn't caught by the person who worked on this before. Well, you can see I got the assembly apart. This is the old resistor, and it looks like that on the inside. Yeah, just a bunch of carbon. And then each of these components, these are both capacitors, they each tested good. This resistor tested good. So now we have a proper 39 ohm resistor on here, metal oxide, and we can get that installed in the board right now. Alright, here's what happened. So there's 7 carbon comp resistors. Not much left of this one here, obviously. And we have 2 1.5K resistors at 1 watt. We have 2 39 ohm resistors at 1 watt. We have 2 5.6 ohm resistors at 1 watt. And then we've got this guy right here. This is a 27 ohm at 2 watts. So basically what I did is I replaced all of them. And I'm very glad I did this because I want to show you what some of these are measuring at, because it's not good. Let's go to ohms. So this one, can't measure it obviously, but you know, we're supposed to have 39 right here. We've drifted up to 43. So, you know, 10% of 39 is 3.9, so we've already exceeded 10% tolerance. Over here we've got 1.5Ks. This one measures at 1.6, and this one measures at 1.57. So this one's almost there, and that one's, you know, we're getting away from it because, you know, 10% is the silver band. But this is the worst one right here. This is supposed to be the 27, and we've got the gold band on it for 5% tolerance. 40. That's really, really bad. Can't have that. And then over here we've got our 5.6ers. 6.2. So that's already on the edge of being out. And 6.54. 6.4. Yeah, not good. So I've got new resistors, you know, you see them right there. One's buried under here, and then there's a few others you can't really see, but they're all in spec. So I'm really glad I did this. They're also higher wattage ratings, so you know they can really take the heat, and we don't have to worry about them getting too hot or being too weak for this. You know, this amplifier is a really good example of doing the best with what's available to you. You know, in the early 1970s, this is what they had to offer. And, you know, basically these transistors, these components are being pushed to their absolute limit to achieve the 120 watts per channel. So that's why you see some issues with these. You have some reliability issues, but, you know, today we've got metal oxide resistors that are much nicer, much more powerful, and that's really going to contribute to increased reliability of this unit here. So I think I'll put this left channel back together right now and then test it to make sure everything is okay. Then move on to the right channel and do the exact same thing over there. But before we put this back together, I decided I'm just going to do new mica insulators and clean off this heatsink, because I showed you earlier how sloppy of a job the previous tech did when they installed these NTE transistors. They are up to the task, by the way. They're perfectly suitable outputs. I'm going to leave them in. We do have the originals on the other channel over here. We'll see if the channels behave in the same way on the scope when we go to test it when we're all done. And then maybe we'll just replace all 8 for fun. I don't know. It gets a little expensive these days getting up. It's like $5 a transistor, so you're looking at $40. I know that doesn't sound like a lot, but when, you know, this part is 10 cents, those resistors were 10 cents. It's like, you know. And you've seen me do this in my How to Restore Marantz and Pioneer videos, but basically all I'm doing is I'm taking Dow 340. I'm just going to put a little smudge right there. And then the only change today is I've upgraded to these foam Q-tips instead of the cotton ones, so I won't have the fibers everywhere. I haven't tried it actually, so we'll see. And all I'm going to do is I'm going to start with the first transistor. I'm going to take this and I'm just going to put a very light amount of the Dow 340 across this entire body. With this Q-tip, we're going to avoid the leads of the transistor because we don't want that there. Make sure I've got nice full coverage. And then all I'm going to do is drop this mica right on top. Like so. Then we're going to do the same thing. We're going to put this on the mica insulator as well. So that way, when we go to put this together, there's going to be no compound that you can touch on the outside here. You're not going to get it on your fingers. It's going to be completely covered up. If you don't do it in this order, you'll end up like we found it, We'll end up with a bunch of heatsink compound all over the leads, and it'll be terrible and look awful, and that's not what you want. So that's one ready. We'll set it off to the side here, and we'll just do the next one. Okay, so I've got this fully reassembled now. Well, the board unit itself. Let's go ahead and do this. Let's plug her into the dim bulb and turn it on and see what happens. Let's turn on the power first. Okay, let's go. Very good. Very good. Relay click. Totally. Awesome. Alright, let's start making some checks here. First, let's do DC offset. You can kind of see that, I suppose. Let's go right at the back here. And the left channel we just took care of. Pretty high, and that's because I was messing with the pot. I cleaned it a little bit. So let's use some clips to get a better connection. Let's see if we can bring that down. We sure can. And yeah, we can get it to go the other way, so that's pretty good. Come on down. Ooh, not bad. And by the way, all I did to clean these was I just sprayed a bunch of the, contact cleaner inside of there. X-Ray Tony B said, do not spray deoxit in there because it's a wire-wound pot. It's different than a carbon trace one. So that looks great. Now let's look at our bias. And the way we measure the bias on this stereo is we go across the collectors on the power amp. So the way you do that is all I'm doing is I'm trying to clamp to the screws on the collectors here. So there we've got a bias of nothing. So let's bring that in here. See if we can do that. The wire's in the way. Yeah, the bias on this likes to kind of creep up and then go crazy. It's kind of interesting. You have all this travel at the bottom of the pot where nothing happens. So for now, and it says negative because I have it polarity swapped, I'm just going to keep it at 5 for now. And we'll come back to that later. We might see more. I can't remember what I set it to before, but we're just going to keep it at 5 for now. So this amp board is done. I'm going to do the exact same thing on the other side. I'll note any differences if there are any, but I think the next jump cut is basically just going to be this thing back together now. Wrong. I've already found something notable. Look at the amount of grease inside of this heatsink in these holes. Like, you can't... That's like a good 1/4 inch hole right there. It's completely packed full of grease. Look at these things. This is not how you do it. This is too much. Oh, that took a while. But I guess the only thing notable, in my opinion, is we take a look at... Oh, there goes my clip. The resistor in the middle here. I don't remember what number it is, but it's this one here. You can see that it's all toasty back there, and that makes sense because what was in that spot originally is not the same value resistor as what's in the schematic. So I think this had been apart at one point, and that got replaced with a similar value. I think it was like 35 or something when it's supposed to be 27. So, that's kind of annoying, but, whatever. It's a good thing we're going through this, right? So, anyways, what I had going, one's still on there. We're going to set this so we can check the bias first thing when we turn this on. So, I will set our multimeter to I guess we have a millivolts function. I don't use that enough. Set it to millivolts. See, I've got the leads clipped down like that. That's how we're going to see if it's actually working without holding the probes on there. So let us go ahead and do this. See if she powers up. Beautiful. Lovely. Gotta love it. Oh, I don't know why that's on AC. Okay, but yeah, 0.3 millivolts. That is something. Let's make that a little bit more. Let's bring that up to 5 like we did with the other one. See? Look how much it can just kind of take off on you like that. Okay, we're going to put it there. That should be just fine. Now let's move our probes over to the back so we can measure DC offset on the right channel. We are hooked up. That's pretty high, so let's fix that. Just gonna turn this the right way. So we're able to bring it to about 0, but we're at the absolute end of the pot's rotation here. So what that says to me is we might have an issue with yeah, see, look how high I can get it to go. But it's still not... How high can we get it to go? It's still not clicking off the production relay. 1 volt isn't enough, which is interesting. So let's bring that back over here. I don't know what that click was. But yeah, we can get it in, but we're at the max end of the rotation. So that could mean either, since we're on the leash, it's not as happy as it could be, or there's some mismatched transistors in there and we've got an issue. Probably the latter, but as far as I'm concerned, we've got a restored amp here, so that's kind of cool. We just need to make sure we can dial it in just right. I think what I'll do is I'll actually take it off the leash. Let's see if that value is any different. Okay. And yeah, it actually is different, so let's see if it's different in the way we want it to be. It is, actually. Okay, that's really nice. Okay, so see, now I can get it to go up to 100 when I couldn't before. And now I can bring it into about 0. Let's just go there for now because it will drift as it warms up. Let's go check the other side because, since we set it on the leash on the other side too, we'll probably need to readjust that. Or not. Is that just still perfect? Interesting. Okay. I'll take it. I will absolutely take that. Let's double check bias on the right. Bias on the right, we're up to 13. I think that's technically what it's supposed to be, but I like to play it safe with the bias on stuff like this. We're just going to bring that back down to about 5 for now. Let's check the other side now. And the other side we're at about 12. Let's bring it down to 5. Huh. Are we done? Is that it? Is it time for a power test? I should probably reassemble this first. Alright, it's time to do the power test. So I've got my frequency generator up there. I'll turn that on, set it to 1000 hertz, 1 kilohertz. Then down here we've got 1 resistor across each speaker. Now some of you ask for this, I'm just going to show you. It's kind of hectic looking, but that's how it goes. Turn this on. you can see we've got those big brown things, those are load resistors, and they're plugged into the amplifier. And then I've got an oscilloscope probe on each one, and then I've got the multimeter across one of them too. So we're going to be able to measure the voltage with the multimeter. I don't know why it says 1.5 volts right now, it's not even turned on. And then we're going to watch the oscilloscope to watch for clipping. And that's going to tell us when things are reaching max power. Okay, so I'm going to turn it on by plugging it in, because that's how you do it with this amp. We're going to bring these so that they're laying perfectly on top of one another so we can watch them track together. Alright, let's turn on the signal generator. So there it is, we see them each. Let's bring up that volume a little bit. And there we are, we're locked in. And my volume control is a little bit dirty on the signal generator, so forgive me. But as I bring it up, it looks like each channel is tracking together. So that looks really good. That was on the minus 20 dB button, so let's bring it way up. And let's see how, there's clipping right there, so bring that down. 33.42 volts. What does that convert to? 33.42 volts into 8 ohms is 139.6 watts. Not bad. Let's do those one by one. So here's the left channel. We'll bring it up real nice. And there's clipping. Bring it down to no clipping. Yep, 34 volts. Well, yeah, we'll call it 33. And now here's the right channel. See, it looks almost exactly the same, so they're tracking excellent. And let's move the voltmeter to the other channel. Alright, because I only have 1 meter, so now we can measure on the other channel. There's clipping. Yeah, 33.9, so pushing 34 volts. Let's do a temperature check. The heat sinks are not that warm. Just a little warm, but not too bad. So this thing actually appears to be working exceptionally well. And I'll add this too. Before I replaced all these resistors on these boards, I was only getting about 120 watts per channel, and I was getting the overcurrent protection to click in right at clipping. So with these new resistors and capacitors and everything, this appears to be a much better amplifier than it was. So that makes me pretty dang happy. Let's turn this off for a minute. Let's check our DC offset across the stuff. Only 12 millivolts on the one channel. Now let's check the other channel. And only 5 on the other. I'm going to call that good because I don't want to mess with that, really. That being said, the DC offset pot is easiest to get to versus the bias pot. So, okay, you know what? Fine. Watch me maybe electrocute myself. There. All that for 8 millivolts. Okay, let's check bias now. Let's see how we're tracking on each channel. So, on the right channel to check the bias, we're just going to go across the transistors, the collectors of the output transistors, top and bottom transistor. 4 millivolts, 4.0 millivolts. It's a little low, but fun fact, it's kind of hard to turn that pot when the thing is assembled, and I'll show you something in a minute here. Let's check the other side. The other side is 4.5. I'm okay with that. Okay, like I said, I was going to show you something. I'm going to turn on the signal generator again, and I've got just something going through it, and as I increase the volume, check out the bias. The bias goes up with the volume because, it's working on that signal. I'll put it at max at negative 20 right here. We're at about 174 millivolts, and now what I want to do is show you the other side. What is the other side doing? 180.6. Fairly similar. So, this is really good. Really good stuff. This thing is definitely warmed up. The bias is staying low. The DC offset is staying at 0-ish. So it's time to play some music through this thing. I've got the Sansui as our preamp. And actually the power amp on the Sansui has failed, so I need to make a video on that. But it's going right from the phone into the preamp into this thing, so let's hear it. It's so clear. It's like crystal clear. The highs are really something. This is a really good amp. It's just kind of a mixed bag because of how notoriously unreliable it is. But as far as I'm concerned, if you go through and you do what I just did, you replace all these resistors and you make sure your transistors are properly matched and, good substitutes if you need to go that route. I was very fortunate to not have to do any of that. I didn't have to change a single transistor in here. So, also, these NTEs and these Motorola's appear to be behaving in the exact same way, so that's a good reason to just leave it alone. I don't hear any difference in the channels either, but I haven't tried that hard to listen. At this point, I think I'm going to try and listen to this with the Maggies. Might even sell it. I know this was a long one, and I'm happy to be back doing this stuff. This has been a really long time coming. I was kind of intimidated by it, honestly, kind of nervous to work on it in case I missed something, but I powered through. I think I did an okay job. I'm sure somebody in the comments has more recommendations on things you can do to bulletproof these per se, but I'm pretty happy with this result here. So yeah, that's it. Thanks so much for watching. Subscribe if you want to see more, because there's plenty more like this coming, like, fixing this Sansui power amp. I haven't even showed you yet. Okay, I'll see you in the next one.